Good morning. This recording is for Pre-Algebra Chapter 9, Lesson 9, and today you and I are going to study symmetry and reflection. A figure has reflectional symmetry when one half of it is a mirror image of the other half. And for most of you, if you hold your hands up side by side so that your pinkies are showing, you will have, and then you keep your hands about the same shape and distance apart, you're going to have reflectional symmetry. So go ahead and try that real quick. In reflectional symmetry, the line of symmetry that is formed by putting your hands right next to each other is the line basically that goes down between your two pinkies that allows your hands to look almost exactly the same on both sides, unless obviously you're wearing a ring or you're a teenager and you drew on yourself or whatnot. All right. So again, a line of symmetry divides a figure with reflectional symmetry into two congruent halves, an image and its mirror image, or a figure and its image, which is also congruent. All right, so it's possible for a figure to have more than one line of symmetry, so make sure you're looking. This flower-looking thing right here has one, two, oops, I'm using the wrong thing right there. It has 1, 2, 3, 4 lines of symmetry, okay? So we don't count the same line twice. So as you draw through it to the other side, that counts as one line. Whereas this rectangle, possibly square right here, has 1, 2, 3, 4 lines of symmetry. This rhombus here has 1, 2 lines of symmetry. A triangle has 1. This other rectangle has 2. This is probably a square. That's what that first one was. This 1, 2, 3, 4, 5, 6, 7, 8. So this octagon has quite a few. 1, 2, 3, 4, 5, 6, 7, 8. 8 lines of symmetry for that octagon. So there you go. And then this triangle has more than one. 1, 2, 3 sides of lines of symmetry. So you get the idea, right? Okay, so let's go ahead and move on. So, too far. Oh well. All right, so a reflection is a transformation that flips a figure over a line of reflection. Basically, it's kind of like the mirror, and you have to make the reflection you see in the mirror. So the reflected figure, also known as the image, is congruent to the original figure. Together, the image and the figure have a line of symmetry, the line of reflection being the line of symmetry. So I have a figure here. I have triangle ABC, and I'm going to go ahead and reflect it over an image. And that reflection is made using the line of reflection, and later on we're going to call it the axis of symmetry. And also, this is if I do it over the y-axis. If my line of reflection is the y-axis, this is also called y equals 0. And so if I had the x-axis, that would be x equals 0. Actually, no. Excuse me. That's not y equals 0. That's x equals 0. Miss TH, you forgot that x-men fly and y-men run. There we go. That's x equals 0. My bad. At least I figured it out before I kept going. All right, so now we need to reflect the figure onto the other side of the line of reflection. To do that, we need to count how far each point in my figure is from the line of reflection, and then count that same distance from the line of reflection, but on the same line as that. So if I go ahead and look at point A is 2 units from the line of reflection, which means a prime of the image also needs to be 2 units from the line of reflection. So basically, you're just counting how far points are from the line of reflection and doing the same number of points on the other side of the line of reflection. So B is only 1 unit from the line of reflection. So B prime, its image, is also only 1 unit from it, but on the other side. C is 4 units, so C prime also needs to be 4 units. Then you can connect the dots, and you have the mirror image. You have the image itself. Alrighty, pretty easy, right? Pretty easy, yeah. All right, so I kind of like this one because it's a little bit of drawing, it's a little bit of counting, not a ton of math. Okay, so Let's go ahead and graph the image of triangle ABC with vertices A3, 0, which I just graphed down there below in gray, B, which is 2, 3, which is right there, and C, which is 5, -1. Now, we're going to reflect this twice. Once where x equals 2, and then again where y equals -1. And I am going to do them both on the same graph without erasing the other one. So it's going to start getting a little crazy over there, but I think you'll figure it out. All right, so let's figure out where the line of reflection is when x equals 2. Well, it's right there. All right, that's the line of reflection where x equals 2. All right, now let's go ahead and figure out how far is A from the line of reflection. Well, it's only 1, so A prime. C is 3, but B is right on the line of reflection, which means its image must also be in the line of reflection. This is if you got really close to your mirror and like touched the mirror. Kind of looks like your finger is in the exact same spot as your reflected finger, and that's the same thing with your image on your graphing point. If B is on the line of reflection, B prime should also be on the line of reflection. Right there. All right, let's connect those dots. And there we go. I have the mirror image. And notice how they're congruent. If I were to flip the blue triangle over the line of reflection, it would land right on top of the original figure. There we go. All right, so let's do this one more time where we use the line of reflection being y equals -1. I'm going to erase some lines just so it's not too confusing. And there we go. That's the line of reflection where y equals -1. All right, now I'm going to do the points, and there we go. It's super easy. Let me do that a little slower for you, just so that you guys can see it. Okay, so C, figure C, or the original point for C, is right on the line of reflection. Therefore, C prime is also on the line of reflection. A, and notice how I'm calling it double prime. That's because this is the second image I'm doing. Okay, just remember notation from the last lesson. All right, A is 1 unit from the line of reflection, so A double prime is 1 unit from the line of reflection. Now B is, I think, 4 units, 1, 2, 3, 4 units from the line of reflection, so therefore B double prime is also 4 units from the reflection line, and there it is. So connect those dots again, and we have the other reflection. All right, guys, short lesson today. I'm done. Bye. Hope you are doing well.